Now that we've covered object-oriented and functional programming in isolation, it's time to discuss how they can be combined together in practice. In part one of this lesson, we'll first describe how functional programming and object-oriented programming compare and contrast. We'll then discuss the benefits of combining object-oriented and functional programming in Java, and as usual, we'll show some modern Java code fragments that we'll cover in more detail in later lessons. So let's start by a recap of what we've covered so far. Functional programming emphasizes several key concepts. For example, it treats computations as the evaluation of math functions that can be composed together into pipelines of operations. It also discourages side effects and the use of mutable shared state, particularly in concurrent and parallel programs. And finally, it encourages the use of immutable objects that can't change their state once they're initialized. In contrast, object-oriented programming employs what we often refer to as hierarchical data abstraction. In an object-oriented program, the overall design approach is based on stable class roles and relationships that can be extended using inheritance and dynamic binding. In contrast, functional-based approaches typically base designs on algorithmic actions that are implemented as functions. Object-oriented programs encapsulate state that's accessed and updated by methods performing so-called imperative statements. Here's an example you're undoubtedly familiar with if you've worked with Java for any length of time, particularly older versions of Java that use Java iterators, which access and update their internal state while they're traversing the elements in a collection. And of course, in order to be able to implement methods like hasNext and next, it's necessary for the iterators to get access to state and to update their state to keep track of where they are in the iteration and what element to return next. Therefore, in object-oriented programs, state is often made to be intentionally mutable or changeable. In contrast, functional programs and functional programming discourages the use of mutable state, particularly mutable shared state in concurrent and parallel programs. Let's now talk a bit about combining object-oriented and functional programming in Java. Java's combination of the functional and object-oriented programming paradigms is very powerful. In particular, Java's functional features help to close the gap between a program's domain intent and its computations. Domain intent defines the what, in other words, the specifications, the purpose, the intent of the program. For example, the EX1 project in my FP directory in my modern Java GitHub repository has the specification, or the what, of generating and checking S-max count positive odd random numbers and printing which are prime and which ones are not. Conversely, computations define the how, in other words, the implementation artifacts. For example, the EX1 project uses the Java stream to define the how by generating an infinite stream of random positive ints using the ints method on the random class, only allowing odd numbers by using a combination of the filter intermediate operation and the isodd predicate, then checking each odd number to see if it's prime by using the map-to-obj intermediate operation and the checkIfPrime method, limiting the stream to count odd numbers by using the limit operation and the count variable, and finally printing the results by using the forEachTerminal operation and the printResult method. Java's functional programming features help to connect the domain intent and the computations so that the what and the how are better aligned, rather than being quite distant in terms of the way they're specified. Instead, the how and the what are much closer. Likewise, Java's object-oriented features are effective at helping to structure a program's software architecture. A software architecture consists of the major elements or components, their relationships or structures, how components interact with each other, the connectors, and how components can be customized through configurations in a software-reliant system. There's a number of different ways to view software architectures. For example, software architectures can be described from the viewpoint of various stakeholders, such as end users, developers, systems engineers, and project managers. There's a model of software architecture called the 4+1 architecture, which we're going to walk through briefly here to illustrate how object-oriented approaches can help to view the architecture more effectively. One of the key views from an object-oriented perspective is the so-called logical view. This view depicts packages and classes and objects and so on that exhibit architecturally important structure and behavior. And the object-oriented features in Java, things like abstraction, inheritance, and dynamic binding and so on, are very important at being able to express the structure and behavior in a way that can be understood, maintained, modified, and reused over time. There's also the physical view, which shows where and how the system components will actually be deployed. For for example, in computers in a cluster, on a cyber-physical system that's embedded, and so on. There's also a process view, which deals with the dynamic aspects of the system, focusing on system processes and how they communicate. Once again, objects are particularly important to be able to provide the appropriate boundaries for communication and interaction. There's also the development view, which describes the static structure of the software in its development environment. For example, where are files placed within folders in order to provide the appropriate hierarchical decomposition of the software structure. And finally, there's something that's called the use case view, which describes sequences of interactions between objects and between processes, and between objects and processes, and between processes and processes. And these are very important to be able to give end users, project managers, customers, other stakeholders a good insight into how the various pieces fit together. So to summarize this discussion, Java's combination of functional and object-oriented paradigms is highly synergistic. For example, functional programming simplifies the composition, extension, and reasoning about behaviors, whereas object-oriented programming simplifies the composition, extension, and reasoning about structures. Together, functional programming and object-oriented programming can be applied to solve problems that are harder to solve in isolation. So that wraps up the first part of the lesson, where we discuss combining object-oriented and functional programming in Java and some of the benefits that come from that combination.